This is a chapter of polynomial. In this chapter, we'll be talking about the four operations of polynomial: division algorithm, remainder theorem, factor theorem, HCF and LCM of polynomials. Let's start from the form of polynomial first. For every polynomial, it can be written as an x to the power n plus an minus 1 xn to the power n minus 1 up to a10. It seems very terrible, right? But indeed, it's talking about a polynomial can be carrying a certain power. For example, greatest power is n, you have n minus 1, power n minus 2 up to power 1, as well as no power, x to the power 0. And then so to each power of x, then you have a coefficient before it. So for example, like you can have a polynomial like x cubed minus 4x squared plus 5x minus 2. This is a polynomial. And then for example, you can have a very great power, for example, power 9, and sometimes can be missing. And for example, I skip power 8 and power 7, and you have 5x to the power, let's say power 6, minus 4x to the power 5, and then jump to the last term, constant term 7, for example. So all these are polynomials. If you are careful enough, you have heard I mentioned several big terms, including degree, coefficient, and one more term called constant term. So let's take an example of this 5x cubed minus 7x squared plus 2, this polynomial, to talk about it. First of all, when you're talking about degree, it's talking about the greater power you can find in the polynomial. So that's why it's a degree 3. And then next, for each addition and subtraction, then you can cut it and you can cut it. And then so that's why we have 3 terms in this polynomial. So these are the first 2 words. So afterward, then what's the meaning of coefficient? Coefficient is talking about the number before the term x to the power something. But for example, like, let's wait. For example, now you have 5 in front of x cubed. So that's why we say coefficient of x cubed is equal to 5. Like minus 7 is in front of x squared, so we call coefficient of x squared is minus 7. If it's missing for the x term, then we say the coefficient of x is equal to 0. Not very difficult, right? And then finally, there should be a term, or there may be a term, which is just a number, no power of x, and then we call it a constant term. So starting from now on, remember these 3 words: degree, coefficient, constant term, as well as you'll also recall the idea of number of terms as well. Now would you please take a very quick practice, and then for example, like this one, x cubed minus 4x squared plus 5x minus 2, the example I just give to you right now. And then can you list out the coefficients as well as your constant term in this polynomial? Let's take half a minute to do so. All right, and then for coefficients, you have to particularly mention coefficient of, for example, x cubed, x squared, and x. And then you have 3 answers. X cubed, there is a 1, minus 4 for x squared, 5x, and then finally, you have constant term equal to minus 2 over there. After you have learned these 3 special words we need to know about polynomial, now let's come to the 4 operations of polynomial. Actually, you have learned 3 of them in the last 3 years, including addition, subtraction, and multiplication. And so please take very quick several minutes to do the 3 examples by yourselves. The questions are not very hard, right? And now we come to a really hard method called division algorithm. Division of polynomial, talking about division. And there are some words you have learned in primary school, including dividend, divisor, and then, for example, remainder, long division, etc. And you also heard of a term called divisible. So let's see how we are going to do division on polynomial here. In example 5, you can see I'm asking you to find the quotient and also the remainder of the division among the polynomials. You will see a very big one of degree 3 divided by 1, which is so-called small, of degree 1. How we are going to do division in this way? So let's take a look. Now, first of all, you have to write down the polynomial x cubed plus 4x squared minus 5x plus 7 in the division symbol, and then now it is divided by x minus 1, so we first write it. The rule of doing division on polynomials would be, so first of all, try to find a way to delete the x cubed by the xc. So that's why we need to multiply x squared first. After that, this term should be multiplied together, and you will be obtaining x cubed minus x squared. Here it is. So in your experience in doing division of numbers, then you are going to do subtraction of these two layers, in which x cubed cancel, and you have next 5x squared minus 5x plus 7. Afterward, now we are going to delete or cancel 5x squared by the xc. So that's why you choose the plus 5x next. After that, you do the multiplication as follows: 5x and x minus 1, which gives you 5x squared minus 5x. And then finally, we also do subtraction of these two layers, and you've got a 7. So as a result, in this division or long division, you can see quotient will be, so the result here, which is called, okay, this is called x squared plus 5x, while the remainder, that means the remaining part after the division, which is your 7. Comment is a very similar question, asking you quotient and remainder once again, but I will give you the question or the answer will give you a very weird one afterward. Anyway, let's go. You have x cubed minus 2x squared, but bear in mind that, or you have to notice that there's no x term over there. So that's why I would suggest you to leave a blank here and then add plus 5 finally. So it's for your convenience, or for yes convenience, to write down the answer afterward. And it's divided by x plus 3. And now we start. Cancel x cubed by x, and that's why you are going to multiply x squared. And then next, after multiplication, is x cubed plus 3x squared. Next, you are going to okay, we need to cancel the terms first. It's minus 5x squared plus 5. After that, I change to green, and now you're going to cancel minus 5x squared by the xc. So that's why you're going to multiply minus 5, which gives you minus 5x squared minus 15x. And then now you can see the use of blank space here, because can you see that it helps you to put the x term in a column situation. Actually, in these two examples, you will see that for the x squared term are put in the same column, x cubed term are put in the same column, constant term in the same column, etc. So it's easier for you to read the answer as well as do the subtraction, cancellation in your calculation. After that, you will have, be careful that it means 0 here, or it is a 0 here, but 0 minus 15x, which gives you 15x afterward, 5 minus 0, which gives you a 5, and then finally, we are going to cancel the 15x, okay, better not to highlight it, but 15x and x, so that's why we go to multiply plus 15, which gives you 15x plus 45, and finally, after subtraction, you've got minus 40. Is it very weird to you? Because you don't expect that a remainder can be negative. But indeed, when you're doing division of polynomials, it happens quite often. And the main rule about when to stop our division would be, you can see that when you do the division, x plus 3 is degree 1, while this one is so-called degree 0, or is a constant term already. So when you have this one remainder is smaller or smaller degree than this one, then we have to stop. And then finally, the quotient would be equal to x squared minus 5x plus 15. So you take out the answer from the top, while the remainder, that means the remaining part, will be taken out at the bottom, which gives you minus 40. Next, let's read example 7, which gives you another concept as follows. Would you please try to spend a few minutes to do the division by yourselves? And then I will show you the answer afterward and bring you several new ideas or new words to you. So please pause your video for several minutes until you finish it. Alright, I hope you finish it. And then I now go to write the answers very quickly to you. Now this time you will see that the remainder is only 0. And then it's fine because you did have the idea of remainder having 0. For example, if you divide 20 by 4, it's 520 and remainder is a 0. It's natural. And then in this example, I would like to bring you two very important words. You will be seeing it quite often afterward. And then when you have remainder is 0, so there is some other ways to present it. First way will be, we can say fx, the one being divided, is called divisible. It's called divisible by, I think I need to rub away the 20/4, divisible by x minus 2. And so, which means it's about remainder is 0. The other way we can also talk about it would be, we can also say x minus 2 is a factor of fx. So you take the chance to remember these two words in your mind. And thus in this video, we are talking about, we are not just talking about about division of dividing by x minus 2, which is degree 1. We can also divide by a certain term, which is degree 2. So let's take example 8 as a demonstration. So once again, we have 3x cubed minus 5x squared minus 9x minus 7 divided by x squared minus 2x plus 3. So first of all, we need to cancel 3x cubed by x squared. So that's why we have to choose multiplying of 3x, which gives you 3x cubed minus 6x squared plus 9x. Afterward, after the subtraction, you have x squared minus 18x minus 7. It's not the end because can you see that it's x squared here, it's x squared here, and then so that means our cancellation can continue. This time we pick a 1, which gives you x squared minus 2x plus 3. And last is minus 16x minus 10 over there. To this stage, can you see that I have only minus 16x left behind, but it cannot be further divided by x squared as follows. And we will say because the remainder having a degree less than the divisor. So that's why we have to pause and we obtain the answer already. In which now you can see if the question is just asking me remainder, then you can just write it's minus 16x minus 10 for the answer.